and welcome back to STEM Camp. My name is Amy. I'm another one of your camp counselors. And in this session, we're going to get involved in some really fun free building challenges. In your last session, you built with build instructions. You built the supercar, you tested it to see how fast and how far it would go, and I know that was a lot of fun. In this session, we're going to do building without build instructions, which is called free building. We're going to do some easy free building challenges to begin with, and we're going to build up to the tallest tower challenge where you try to see how tall of a tower you can build using your Vexco pieces. Let's get started. So the first thing we're going to build using our Vexco kits is a flagpole, but not just any flagpole. It's going to be the kind of flagpole that an astronaut would put into the surface of a new planet that they discovered or the moon. And before we get our flagpole built, we're going to need an astronaut. So the first thing we're going to do is put together the Vexco mascot, Colonel Joe. So if you haven't found Colonel Joe in your kit yet, you're probably going to find it right here beside the pin tool. But I have already found my Colonel Joe. So I'm just going to get the pieces of Joe out and show you how to build it. So you go ahead and follow along. Go ahead and get Joe out. If you haven't opened these pieces yet, they're in a little plastic package so you can open them up and set your pieces out in front of you. Now, just as with all of these videos in camp, if you need to rewatch part of it, that's totally fine. Just pause the video and go back and watch whatever section you might need to watch again in order to follow along. Okay, so hopefully you have your little Joe pieces out here, and I am going to zoom in just a little bit so you can see better. So putting Joe together is quick and easy. We're going to start off by picking up this little torso piece right here. You can tell this is the front because the back has this notch in it, which we're going to use later to attach the backpack. But for now, we just need this piece and then this little pelvis right here. And what we're going to do is, these are kind of ball and socket joint situations. So we're just going to take the pelvis and stick that ball into that socket. And now we have Joe's torso, basically. And next up, let's get the head. We want Joe's head to face away from that little notch in the back, right? Because the back is for the backpack. So there we go. We just snap the head on in the same manner. Let's go for the legs next. Only thing to worry about is making sure that Joe's feet are facing the same direction as his face, or as her face, or as their face. Okay, we'll go ahead and, do the other leg. Same thing. And then we've got Joe with legs, but no arms. That's okay. We're going to fix that right now. So the arms have two pieces. There are these little shoulder parts right here. So first we'll snap in the shoulder parts. Just like we were using a pin in the kit, it just snaps right in the shoulders. We want to turn them so they're facing the right direction now. All right, and then you've got that. Next up are our little arms, more ball and socket joints. Just make sure that that Joe's hands are facing the right direction. There we go. There's Joe. The last piece that's left is the little backpack. So if we flip Joe over, you can see the backpack has like a little tab on it, and that tab just goes right into, the notch on the back with the wider part at the top. And there we have it. We've got our astronaut, Colonel Joe. Okay. Colonel Joe also comes with some stickers that you can add if you want to, but for now I'm just going to leave this Joe blank. And this Joe is ready to have a flagpole. So let's get started with free building. So doing these free build activities can help us get to know how the pieces in our Vexco kit attach to one another and how they work together. And before we start building, I just want you to go ahead and open up both your bins and see what you notice here about the colors and the sizes of the pieces. So if you look here, going this direction on this side of the kit where all of these beams are, they start red and they're small and they get a little bigger, turn green, a little bigger, turn yellow, go and get bigger, 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 all the way up to these long light gray pieces. On the other side, it's exactly the same with the large beams. They start, the smallest pieces are red, and these are the largest pieces, the same light gray color, right? This is even true for the pieces in our jewel cases, the small pieces like the standoffs and the pins. They are all the smallest ones are red and they go up in size in the same manner. So understanding the organization and the pattern of the colors can help you to find the pieces that you need in the kit. Another thing I'd like you to do is just take out any large beam or any beam at all really, and hold it up and look at the side of it and see what you notice. You will see that we have these little notches that are evenly spaced on the sides of the beams and the plates, and there's a flat place between them. The flat places between the notches, these are called pitch units, okay? And really what they are is exactly 1 centimeter wide. So we're going to use that to help us do some measuring later, and I wanted to point it out to you so you were aware of that as we begin to build. All right, so I'm going to put that back in here, and we're going to get started building a flagpole for Joe. So from your kit, go ahead and take out this jewel case with the pins, also this one. Take out three of the small red beams, 1 orange beam, 1 4x8 plate here. These flat pieces are called plates. The wide flat pieces, I should say. And then that's it. That's all we need for now. So I'm going to go ahead and close these up, push them away just a little bit so I have some space. And then I'm going to get you a slightly closer camera view. Okay, so let's get started building our flagpole. So what I want you to do is open up this jewel case here, and we're going to actually take out 3 of these pieces, these orange pieces here. And these pieces are called standoffs. And you can see that they are long. There's also some shorter blue ones, which we don't need right now, but I wanted to point that out to you and show you it's the same color-coded organization, right, where orange is bigger than blue. That's going back in there for now. We need 3 of these. We're going to close this up. There we go. Okay, so to start building our flagpole, we need a base. It's going to be the surface of our planet. And we're just going to attach one of these standoffs into the base. Now, standoffs are useful when you need to attach 2 pieces together with distance between them. And that's why there are different sizes of them too, so that you can have different amounts of space between pieces. So to build our flagpole up, the next thing we're going to do is take one of these red beams and attach it, and I'm going to put it in the, not the middle hole, but one of the side holes right there. And you can see I have space between my pieces. So when you're building, that might come in handy, right? You might need to use a standoff to make space between 2 pieces. I've got a start on my flagpole, but I want it to be taller. So I might as well just take another orange standoff and make some more space between pieces here. So this time I put it on the opposite side because I can't put it here, right? There's already something occupying that hole. All right, there we go. It's a little taller, but I'm going to keep going. And again, attach another red beam to my flagpole. All right, it's getting taller, but I think I can go 1 more. So I'm going to go ahead and add 1 more standoff and 1 more red beam. So I have a situation kind of like this. There we go. Okay. Now this is my flag. This orange beam is my flag. So I'm going to add it to the top. Now to attach it, I need some kind of connector. So I'm going to use a connector pin. You've already used these when you built the supercar, but that's what these guys are for. These red pins come in so handy to attach one piece to another. So to do that, I'm going to just stick 1 connector pin into this available hole right here on the top of my flagpole. And then I'm going to attach this orange piece because this is my flag. All right, there we go. I have built my first ever Vex Go free build, and it is a flagpole on the surface of whatever planet or moon you want. And we can set it up here. We can add Colonel Joe in there somewhere if we want to. There we go. All right, let's take a front view so you can see. And there we have Colonel Joe standing here on the surface of his newly discovered planet, whoops, with your first Vexco build, the flagpole. All right, I'm going to set Joe aside with the flagpole over here. We don't need them right now. He can bask in the glory of having discovered a planet. Now, how did Joe get to this planet, though? That's the thing. He had to take a rocket ship. And so in order to take a rocket ship anywhere, you have to have a launch pad. So that's the next thing we're going to build. Now, when you think about any time you've watched a video of a rocket launching and the rocket is launching off the launch pad is big and very stable, right? It has to be stable so that the rocket ship can successfully launch. Stability means that an object can return to its original solid position if it's disturbed. So what we're going to do is try to build a very stable launch pad. And we're also going to build a launch pad with some constraints now. Our launch pad is going to be 3 centimeters high, 10 centimeters across, and 4 centimeters wide. So we're going to use pieces from the kit that will allow us to make a launch pad that meets these requirements. So we can use any of the pieces in our kit that allow us to make a stable launch pad that meets these dimensions. But how are we going to know if our launch pad is 3 centimeters high, 10 centimeters across, and 4 centimeters wide? We're going to know because we're going to measure using a beam. So I'm going to take out a beam that's at least 10 centimeters across. Remember how I showed you the pitch units? Actually, let's get this one because it's harder to see the black. So we'll get the white one. So remember how I showed you the pitch units and how each one is 1 centimeter? So this one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This beam is exactly 10 centimeters across. So that is basically how much distance there needs to be across the top of our launch pad. So we're going to use this, and we can also use this to measure to make sure it's 3 centimeters high. 1, 2, 3 centimeters high, or 4 centimeters wide. So let's put this aside and we'll use it for measuring. And now I want to think about what pieces in my kit will serve the best purpose for my launch pad. And since I want it to be nice and stable, I'm going to get out 2 plates to be my base. So you follow along and do that as well. So we've got 2 plates here. These are the light gray ones. All right. The next thing I'm going to do is get out some connectors. So I'm going to go into this kit and I'm going to take out my 3 orange connectors because I think these would be really good pieces that I can use to connect my base to the top of my launch pad. Okay, so I'm going to place my connectors with their flat side facing the same. Oh, trouble there. There we go. With my flat side facing the flat side here so that if you notice there on the connectors, there's a side with some bumps. My bumps are pointing in, I guess, or away from the middle of my launch pad. That's how I'm thinking of it. So I'm going to do the same thing on the opposite side. So I have 2 symmetrical pieces here. They look like this. I put them right in the middle. You go ahead and do that too. So you can use 2 orange connectors and these 2 pieces here. And you can see that the orange connectors are similar to standoffs in that they allow some space between pieces because the other connecting pins are on that side. And that's great for our purposes here. You know what I'm realizing? I need to be sure that these are 3 centimeters high. So let's measure them really quickly to be sure. So I'm going to take my my beam that I'm using for measuring, and I'm going to place it right up against the side of my connector. And look, I can see that, yes, it's 1, 2, 3 centimeters high. Fantastic. So we've met that requirement. It's at least 3 centimeters high. So then I can get, I don't know, a beam and just attach it to that. And I should be in business, right? So let's do that. Let's get out one beam, attach it to both sides. Oh my gosh, there we go. There we go. All right. And I measured this white piece before. I know it's 10 centimeters across, right? I can compare. Yep, I've got it. It's 10 centimeters across and it's 3 centimeters high. So I've met 2 of my requirements. However, I'm noticing something. I'm also supposed to have a 4 centimeter wide launch pad. And as I put this up here to measure, across, it is only 2 centimeters wide. So one of these large beams is not wide enough. I'm going to need 2. So I need to rethink my design a little bit. So I'm going to use a second one of these since I know 2 plus 2 is 4, and that's going to give me 4 centimeters of width. But I need to figure out how I want to attach these together. Okay, so I want them to be in the middle, first of all. So I'm going to go ahead and then take this off and give some space for another beam. So I'm going to slide these down basically 1 hole away from the middle. You can do the same. So I've got 4 holes on this side and 2 on the other side. Now, it's not imperative that your beams are centered in the middle, but I just like that symmetry, so I'm doing that. That's not one of our requirements, but I feel like having it symmetrical. Now, here's the thing. I've got this is going to be my 4 centimeters wide, my 10 centimeters across, and my 3 centimeters high. But I only have 1 more orange connector that's 3 centimeters high. So I've got a little conundrum. I've got to figure out how I can make another piece to support the other side of this beam, right? That's also exactly 3 centimeters high because I've only got 3 of these orange connectors. And if I just use what I've got here, oops, that one's backwards. Let me flip it. Okay, if I just use what I've got and attach this side, this is not going to be stable, right? That's not stable. My rocket ship cannot launch from there. So I need something to fill this space here. This is exactly 3 centimeters of space. So I'm going to get a little creative, and you can do the same. So what I'm going to do is take out 4 large beams from my kit, and I'm also going to take out 1 green connector. And what I'm going to do is put these together to make a support that's 3 centimeters tall. I figured out that if I stack up my red large beams and measure them, they're 2 centimeters. That's about 2 centimeters right there. So that's 2 of my 3 centimeters. And then my green connector is also a centimeter. So that's my other 1 centimeter. I measure it there. Add them together, and I'm going to have a 3 centimeter support. That works, but I have to put them together. So like I said before, our connector pins are what we use to connect pieces together. We're going to connect these red beams with the connector pins. But we have to think carefully about how we do it, right? There's only so many holes. So if I start off by taking 2 connector pins and putting them in the opposite corners, I can go ahead and snap the next one on, right? But that leaves me with only 2 other holes for an option. So this time I'm going to have to use these holes to connect them. The middle hole right here actually doesn't have a round receptacle. It has a square-shaped one, and that is for shafts. So that's not going to work for us right now. So we're just going to use 2 red connectors in the opposite corners this time. And again, snap it on there. Do you sense a pattern here? I bet you do. So now we're going to do the same thing a 3rd time. 2 more red pins. And then we've got our 4th beam together, and now we have our 2 centimeter chunk of support. And then the last thing we need to do is just add in our green connector. Oops, but look what happened. I didn't think carefully about that last one because my green connector needs 2 parallel holes, and I have used the opposite corner. So I'm going to take that off. I can use my pin tool if I want to and rethink how I'm doing this just a little bit. So for my last one, I'm going to try just using 1 pin, see what happens. Now, if I was going to attach this to something that was moving, it might be an issue, but because I'm going to use this green connector and attach it to this, I'm pretty sure it's going to be stable enough. So let's go ahead and try it. So I'm going to attach my green connector, and then I'm going to have to find a way, whoops, this way, okay, to attach my beams to this plate. So let me go ahead and add 2 more. pins in the remaining holes in the bottom. And here's what I've got. I need this to face this direction. So I'm going to first attach it into the holes right here in my plate. And then I'm going to attach the 2 green connectors right there. Okay, now let's make sure it's stable enough for the rocket to launch. If I shake it, it's pretty stable. It doesn't seem to matter that I only used 1 pin there because there were other points of connection. So there we go. I've got a launch pad here. All right. We've done 2 VexGo free builds, 1 flagpole, and a launch pad for Colonel Joe's rocket. Well done. Just to be 100% sure, we can measure one more time to make sure we met all the criteria. We know it's 10 centimeters across. We know it is 1, 2, 3, 4 centimeters wide and 1, 2, 3 centimeters tall. So it definitely meets our requirements, and we've done a great job with our free builds. Okay, so we've had some experience with free builds, and I think we're ready to begin trying to build the tallest possible tower we can using our VexGo pieces. But before we do that, we need to get ready and organized by deconstructing our flagpole and our launch pad so we have all the pieces that we need in order to start this next part, which is building the tallest tower. So right now would be a great time to go ahead and pause the video, deconstruct your 2 builds and put them back in the kit, and I'll meet you back here right after that. So you're going to need to be sure that you have something to measure with that's at least 48 inches long. That would be a tape measure, or you might want to use a yardstick with a ruler or something like that. And you might need a helper to help you measure a little later on in this video, so keep that in mind as well. All right, let's get started figuring out how to build the tallest tower with our VexGo kit. So what I would like you to do is go ahead and take out 2 of these large white beams. And we're going to take out a connector and connect these 2 beams to get started building our tower. All right, here we go. So I've got 2 beams connected with a connector pin. Great, that's a great start. Oh, did you see that? It's flopping over. Okay, so obviously I'm going to need to make this a little bit more tightly connected. So I'm going to get another red pin because we don't want a floppy tower. So I take this out, add another red pin. So I have 2 points of connection and snap it together. All right, there we go. We have our very first bit of a potential tallest possible tower. But this tower is not going to stand up, right? It's just going to fall over if I put it here and make a mess possibly. So what I need to do is be sure that my tower has a base. So I'm going to go ahead and get out one of the same plates that I used for the base of my flagpole. It's 4x8 plate, and I'm going to put it right there. And then I need a way to connect my plate to my tower so that it will stand up, right? It's not going to stand up on its own. So I need something where I can connect some pins facing down. So there need to be connectors facing down and facing here at a right angle. So the way to do that is going to be first to get one of these pieces. This is called a yellow connector. You can see that it has 2 pins on one side. It's also got the same bumps that we saw in the orange connector earlier. And it's got holes in it that we can use to add connector pins to. So if I attach this yellow connector to my base, go ahead and do that as well. I can see that it's standing up, but I'm going to need a way to attach my tower to my yellow connector. And I'm going to use connector pins. So I'm going to get out couple of these red connector pins and add them to my yellow connector like so. And since they're now facing this way, I can attach this tower at the right angle to the base. So here we go, snap it on. All right, check it out. It's a freestanding tower. All right, so we have a freestanding tower, and that's great. But it's not very tall. We need this tower to be taller. So I'm going to give you a little bit of a challenge. So your challenge will be to go ahead and build your own freestanding tower. And here are your constraints or your requirements for that tower. It needs to be at least 80 centimeters or about 33 inches tall. You can use two white large beams, two black large beams, two gray large beams, one 4x8 plate, 12 connector pins, and one yellow connector. And that's it. So for now, that's your challenge. Using those pieces, you're going to go ahead and pause the video and try to build this particular iteration of the tallest tower. And then in the second half of this session, Elena will come back and take you through some more ideas to help you build the tallest possible tower with your Vexco pieces. I'll see you back here in camp very soon.
Welcome back. My name is Elena, and I am another one of your camp counselors for Vexco STEM Camp. Now, how did your tower building go? I know when I built my tower, I didn't even get all the way to the height that we were supposed to, according to Amy, before my tower fell over. And it's constantly falling over, no matter what I do. So I can't get quite to that height that Amy was telling us to get to. So what we are going to do, because I guess you might have had the same issue as me, is that we're going to go through and start to fix our tower and change the build so that we can build an even stronger and taller tower. Now, when we look at our tower, put it up one more time to let it fall over. As it starts to fall, it's starting to bend. And as it bends, gravity starts to pull on our tower, and then it pulls it all the way down. So gravity is pulling our tower down to fall down. But I really want to focus on that first thing that we notice, which is the bending right here. So we're going to add rigidity to our tower. Something that is rigid is really stable and it's not prone to bending. So it's very hard to bend something that's rigid. So we're going to make our tower more rigid by adding connection points. So the first thing that I am going to do is I'm actually going to switch kits. I want to get out my red pins to add extra connection points. So I'm going to pull out my bin of red pins. My pin tool keeps trying to escape. Oh my goodness. And I'm going to set that to the side because all I need are these pins and my tower. Also, just to make it easier, I'm just going to take off the top part of my tower and set it aside. So that way we can focus just here on this bottom section. So when I say connection points, I mean everywhere that is connecting two pieces together. So right here at the very bottom, we currently have two connection points because we have the two red pins connecting our yellow corner connector to this white large beam. So if I take this apart real quick, I can see my pins ended up on either side, but the first thing I'm going to do is add more connection points. So I'm going to add, let's see, two more pins here to the bottom of my yellow corner connector. And I'm going to line this back up. So now I have 4 connection points here. So I have extra rigidity if I try and pull on this. There's not very much bending at all. It's all staying really straight. So let's go ahead and do the same thing with this overlap here and add more connection points. Now you might be wondering, Elena, where are we going to add these connection points? It's already connected at the end. And that's where we're going to have to start changing the design of our tower. So I'm going to pull this off. I'm going to pop this red pin out and put it right back here. And I'm going to add more red pins to my white large beam. So rather than adding them right next to each other, you also can leave extra spaces if you want to. So I'm going to add red pins, have the 2 pins, 2 holes open, and then 2 more pins. And then I'm going to overlap this large white beam. So now I can see there's 4 connection points between these. And if I try to bend this, it's really rigid. It's becoming really stable. So now this is a much better base for my tower because it's not going to have as much bending. So let's take a look at what that looks like if we connect our tower back together. So I'm going to snap this back together, get my red beams lined up. Remember, we only added extra connection points here at the bottom and at this first overlap between beams. But if I let go, now it's standing. So you can see just from adding a few extra connection points, it's adding rigidity to the tower at the bottom, and now it's able to stand on its own. Can you imagine what would happen if we added all these extra connection points all the way up? That would be even better. And there's actually another way we can add rigidity to our tower other than just adding these connection points. So the next thing we're going to do for our tower is add extra support to make it more rigid and also to make it more stable. So stability is the ability or how if your object can return to its initial balanced position after it's been disturbed. So after I'm touching it like this, it's been disturbed and it's not very stable, it's falling over. So we want it to be able to return to its stable center position. So we're going to add that stability by adding bracing. Now there are a few different ways that you can add bracing, and there's probably some bracing you've seen before in your day-to-day life. So let's take a look at this porch. This porch right here has a lot of similarities to our tower. It has a base at the bottom. It has these vertical tall pieces coming out just like our tower. But then it has additional supports where it's supporting the roof of the porch. And now we can see that there's different types of bracing that's helping the roof. We have this horizontal beam going all the way across here that's adding extra support for our roof with horizontal bracing. We also have this diagonal piece here that's adding additional bracing as well as more vertical pieces. So you have to think about all of the different ways that we can add bracing. We can add it vertically, horizontally, or diagonally. So the first kind of bracing that we are going to add is vertical bracing to our tower. And we're going to do that by using our structure bin here, and we're going to get out a gray beam. Let's actually do one of the long ones here. So our longest gray beam. And you can see we have this overlap between the 2 white large beams here. But we could add additional overlap on this side. So then there's a beam on this side and on this side to add extra support to make it more stable, to add that rigidity. So I'm going to flip this over and let's go ahead and plan out where we want our pins to connect this beam to the rest of our structure. You want to make sure when you're planning out where the different pins go that you know what spaces are already occupied and what fits on your beam that you're adding. So I'm going to add my pins on this side and then snap my beam in. Now, I remember we just talked about connection points. So I want to have a few connection points here for my bracing. So I'm going to add 2 red pins on top, 2 red pins. And I'm going to add 2 more red pins down at the bottom. So I'm going to line up my beam here, and then I'll snap that in. So now I have this vertical bracing being added to our tower. I can see when I put my tower up and I press on it, it's returning to that center location. So it's a much more stable build instead of falling over. So we're just done that by adding this vertical bracing here. Now, if you remember, there were two other types of bracing. There was horizontal bracing and diagonal bracing. So we're actually going to use both of those together. If we look at our kit and we wanted to add a diagonal brace, it looks like it'd be hard to add something diagonal. We have all these straight pieces, rectangles, some squares, but we can add diagonals by changing our orientation, by changing how we're looking at an object. So instead, I can actually add another pin. I'm going to use another one of these long gray beams, and I'm going to add a pin right on top where I have a hole here. Snap that into the top there. And now I have a diagonal brace. You'll notice though, if something were to push on my tower from the side, the brace doesn't do much because it's swinging around because we only have that one connection point. What we can do is use some of the other pieces we've been talking about and actually add another connection point here at the bottom to support our diagonal brace. So we're going to do that by expanding our base, which also expands our horizontal brace. I'm going to do that by adding another one of these dark gray plates because I want it to go long ways this way. So how can I connect these two plates together? Let's think about this. We can use other pieces that we've already used in the kit to overlap our plates here and connect them together. Now it's a little hard to see with my whole tower in the way, so I'm going to take my tower off, set it aside for a minute with my diagonal brace there, and we're going to put this back. So I know that I want my plates to overlap right here. If I look at what's in the kit, there are a lot of different options. I can use some large red beams and overlap that here. Let's try that first. So I'm going to put that right in the middle. And because we've been talking about connection points adding stability and rigidity, I'm going to do all 4 pieces and then snap this right on top. Let me line it up, snap that down, and now these are connected. So that's great. There are other ways you could do this too. You could use some of these smaller beams. You could connect it with one of these angle pieces and overlap it like this and add connections. There's a lot of things you can do with your Vex Go kit. So while you're following along with me for some ideas for your tower, when we start to build onto your tower for an even larger challenge, remember all these ideas that we're talking about. So I'm going to come back up. I'm going to reattach my tower right here. And now we need to figure out how to connect this diagonal bracing to this plate here. And what I want to do is think back to what we did when we were using our yellow corner connector. So I'm going to pull out another one of those yellow corner connectors because I want a piece that connects to the base and also can connect vertically to one of the holes for my diagonal bracing. So I'm going to grab another one of these. I'll set this aside. Keep this open because we've been using this kit a lot. And now I'm going to go ahead and snap this into place. And now what we can do is we can overlap here and figure out what hole of this diagonal brace lines up with the holes of my corner connector. Now that's really important to try and figure out so you know where that's going to go. Now I can see in this top left corner, my holes are lining up. So I'm going to put a pin right here in the second hole from the end. I'm going to line that up and snap it in. And now my diagonal bracing is connected. So when I push my tower to the side, it's really stable. It's not moving at all. It's actually moving the whole tower to the side. So now we've added vertical bracing, we've added diagonal bracing, and we've even increased the base of our tower, which is adding extra horizontal support as well. So now let's look at where we're at with our tower. We can see it's very rigid at the bottom because you have all these connection points and there's very little bending. Most of the bending is happening here at the top where we didn't add those extra connection points or anything like that. We also have that extra stability where our tower is going back into its center position, its balanced position. So it's a very stable tower because we added the bracing. Now, if we go back and look at the base of our tower, we've expanded it out to support this bracing. But let's think about what buildings tend to look like. Do they tend to look like long sticks like this? Maybe with a little piece poking out at the bottom? No, they have much different shapes. If we look at some examples of skyscrapers like this here, you can see diagonal bracing on this one on the left and the one in the middle. That's adding extra support. That's really the roof, but it's all for those different supports. But you'll notice all of them, except for this second one here, have a wider base at the bottom. So they have a wider bottom and then a skinnier top. So this is also to add additional support and to help buildings grow taller and taller. Even with this one example that's the same width the whole way up, it still has a big base and then it maintains that width all the way up. It's not just a spire or some skinny bit poking out like here at the top of the first and the fifth building. So let's go ahead and add on to our base to widen it and give our tower even more support and stability. Now, as we make our wider base, we may need to change some things that we've already built onto our tower, and that's totally okay. For this, what I want to do is I want to make my base wider so that there's more room to add supports on either side here. So right now, there's not a lot of space for that extra support. So I'm going to change the layout of my base so it actually includes both of these dark gray plates and that we move all of this over so there's more space and we're not as close to this connection point here. So as we're making all these edits, what I'm going to do is I'm going to take the tower off. So I'm going to disconnect both of the yellow corner connectors. I'm going to move this off to the side so that we can connect this together to make a wider base. So we've already experimented with how to widen our base using a connection point like this. We also can use some of these skinny beams and actually line it up because this is the perfect width of these two gray plates put together. So I'm going to add connection points here. I'm going to add them at the beginning and the end of each plate. So I'm adding 4 to this side. And then I'm going to connect this beam on top. Just like that. And then just for extra stability on the base, I'm going to do the same thing on the other side. So I'm going to grab another one of those beams, grab more red pins, using a lot of red pins, but that's okay. You want to use these extra connection points so that way you have a more stable structure. We're going to snap this on top, and now we have a much wider base. So let's go ahead and plan out where we want our piece to connect. Now, I want to make sure that we have as much space as possible on either side because I want to add supports on these two sides. So I'm going to snap this right into the center of these two plates, and then I'm going to line up this, and now we have a little bit more space all around the base of our tower to add those additional supports. So far, as we've been adding extra support to the bottom of our robot, we've just been using red pins to connect everything and then some corner connectors to attach it to the base. So I want to show you some other ways that we can expand the size of the base of our tower without using some of these pieces, using something a little different. The first things I want to show you and remind you of are what you used in your launch pad to keep it above the two plates. And those are these orange connectors here. So I just need one. Go ahead, put the other one back. This orange connector can allow us to attach something like this. And now we can add another beam here on this side to connect out and to add extra support to our tower. So with this orange beam, as I look at my base, I can see my orange beam actually lines up with this border here, which means I probably need to move my tower so I have more space. And that's the great part about doing all of this testing with VexGo, is that we can just pick things up, move them one space down, pick them up, move it one space down, and now we have space for our beam. So I'm going to go back into my kit and I'm going to grab my last of these white beams, and I'm going to snap that in. But there is nothing to connect my beam to the base of the tower. So now what we need to do, if you remember, is we can grab one of our yellow connectors and attach it here to the bottom. There's also different types of connectors that we could use too. So we've used the yellow ones a lot, but one of my favorite types of connectors is actually inside of this bin with the standoffs. They're these little tiny red connectors. So that way I could snap this in to the wall here. If we look, and now I can add a pin between my white beam and this connector, and it would be connected actually to the wall that I made on the base. So let's go ahead and grab a red pin and we'll add that in. Remember, you always want to make sure that everything is lined up. This could be a little difficult, so I'm actually going to take my red piece out, my connector, add the pin. You can see it just goes right inside there. And then I'm going to snap it on the base and into my beam at the same time. So now I have additional support on this side of my tower. It's very stable. When I push this direction, I'm going to hold the base just so it doesn't scooch around. But when I push this direction, it's barely moving. So we have a lot of rigidity and stability added in this direction. So now let's add it in the other direction. So I'm going to rotate this around. And now we can do something very similar using another piece that's just like this orange connector. And what we can do instead is use one of these smaller green connectors. You'll notice these connectors function really similar to a standoff to create space between pieces. So that's what we're doing here, is we're creating space between pieces as we add on that green connector here. Let me grab, I think orange might be the right size here. Snap on our orange piece. And now we have this connection here of this green connector and our orange beam. And then we can do the same thing. We can choose how we want to connect this to the base. Now what I see is something really cool that you may not have seen before. I see there's this nice space right between my yellow corner connector and my orange large beam. You notice that space? I bet a standoff would fit right there. So to connect this, instead of using another yellow connector, I actually can add this into the center because we left that gap there. Snap that to the bottom of our orange beam, snap that to the top, and now we have a connection point also for this orange large beam. So now if we look at our base, we've got connection points all over connecting our tower to the base, creating that wider base so it can help stand up. We've got diagonal bracing. We've got vertical bracing here as part of that to add rigidity to our structure. And now we're ready to add on even more to the top of our tower. Now that we've learned all about how to add rigidity and stability to our tower, your challenge is to go out and build a tower that's at least 120 centimeters tall. Now that's one tall tower. So you can use anything that we've used so far in our kit. Beams, plates, connectors, pins. Use all of that in order to create your 120 centimeter tall tower. And then come on back here. How did it go? I hope you had a blast building your tallest tower. Mine is even taller than what you can see right now on the camera. How cool is that? If you want to, you can go ahead and keep adding on to your tower and making it taller and taller. But remember, before the next session, you need to take apart your tower and put everything back in your Vex Go kit. So that way we are ready to go as we start our next session. I hope you had fun building the tallest tower, a flagpole, a launch pad, and that you are ready to do our next Vex Go build. We'll see you in the next session.